Alright, so we're going to call this, let's call this review. Oops, let me change this thing around. I always forget to do that. Let's make that black. Okay. Oops. Alright, now we're ready. Let's call it review test. And it's chapter 1, right? And what do they call it? What do they call it? Form what? 2C? Is that what it is? Okay. Alright, so it's form 2C. And let's do this. Let's not start from the very beginning. We kind of talked about those first several problems when we went over them. Let's start with number 6, okay? Let's take a look at 6. It says, find the length of DE if what? If D is between points C and E. You know what I'm going to do with this? I'm not just going to try to put a bunch of numbers in or add or subtract or do whatever. I want to see it. I want to visually, I want to look at it. All right, so I'm going to write a little line segment right here, and I want to put some points on there. So let's see, what does it say? Find the length of DE if D is between C and E. Well, C's right here, E's right here. Now it says D is between. Does that mean it's right in the middle? Not necessarily. I mean, it could be, but it's not necessarily. It's just got to be, you just have to have C on one side and E on the other side of it, right? So, I don't know, let's just put D right there. It could be anywhere, couldn't it? As long as it's between C and E. You with me so far? Yes. Let's read on. It says CD is 6.5. So there's 6.5. And CE is 13.8. CE, oh, that's the whole thing, isn't it? So that's from here to here. What did I say it was? 13.8. Alright. And let's see. They tell you anything else? That's all they tell you. They say find the length of DE. Alright. So I want to find from here to here. Instead of calling it DE, let's do this. Let's just call it X. Is that alright? Just make it a little easier for us. Okay, you with me? Alright, now look. Now you can see what's going on. I mean, some of you guys might be able to just read the problem and then do the math. Alright, I understand that. But some of us, myself included, need to see it. So I draw it down, I write everything that they tell me, and now I can make a better judgment on what I should do here. Now remember, we're trying to find this right here, this X. That's right, because look, you got the whole thing, right? And they give you a little bit of it, so how do you find the rest of it? You just subtract. That's all it is, okay? But drawing it out sometimes makes it really pop out to you, you know? And you can see it and you're like, oh, now I see what I do. Because if you just read it straight from the problem and just decided what to do, it may not make that much sense to you. So you draw it out, you look at it, say the whole thing is 13.8. I know this little bit right there. So how do I find from here to here? I subtract it, right? Take this away from the whole thing, or take this away from the whole thing, and I got what's left over. So let's do that. It's 13.8 minus 6.5. What's that? 7.3? Alright, and that's DE, isn't it? And there you go. And that's my work. You know, some of you complain, well, I couldn't show any work. You know, oh, I just did it in my head, or I did it in my calculator. I don't care. Do it in your calculator. Do it in your head. But write it down, okay? I want to see the problem written down. I want to see where it came from. Now, on a quiz and test, I'm not all that picky. I'm not going to take points off if you don't show your work. I'll just be honest with you, all right? I'm looking for answers on a quiz or a test. But homeworks, what am I looking for on homeworks? Looking for your work, okay? I'm looking to see how you got to your answers, because I don't even check your answers. You know that, right? I told you from day one. I don't even check your answers on your homework, right? Not me personally. I mean, you check them, don't you? Because I always read off the answers, so you should be checking to see if you're getting them right or wrong. All right, so they are checked, but I only grade your homeworks on completion, so and on how much work you show. Let's keep going. Number 7 is kind of close to this, isn't it? It's the same idea. Watch this. Let's put a 7.3 right here. Let me ask you this. What's going on with the 6.5 and the 7.3? What did we do to those two to get 13.8? We added them up, didn't we? We took this section and this section right here. We added them up to get the whole thing. I'm saying that for a reason, because I know what's coming up. I know this problem coming up. All right, so think about what I just said. Do you hear me? You take the two parts, and they add up to be the whole, don't they? All right. So let's draw another one. Number 7, they actually give you the picture, don't they? They put an X here, put a Y around in here, put a Z at the end. Now this time they don't just give you just regular numbers. On one section they do. So they say xy is 8. They put an 8 right there. So from here to here is 8. Now this is a little bit different. Instead of just saying it's x, they say it's 2x plus 7. And then they also tell you the whole thing. And I'm going to do this. That's 4x plus 3. Alright? You understand what's going on here? 8 is this little bit right here, x of xy. From here to here, from y to z, what's the length of that? It's 2x plus 7. Well, what's the length of the whole thing, xz? It's 4x plus 3. What are they asking you to find? xz, right? Now, they don't put anything on top of it. If they don't put anything on top of it, what do they mean? We've talked about this a couple times, not often, but a couple times we've talked about it. It doesn't just say find line segment xz, find the what of xz. The length of, very good. Okay, it's the length. If you don't see a line over top of it, that means find the length of line segment xz. Does that make sense? So we're going to find a number, aren't we? We're finding the length. How long is it? That's what we're trying to find. What's that? No, it doesn't. Oh, they write. Okay, you're right. They put the word the length of in front of it. But if I just did this, I wasn't even looking. But if they did this, that would mean the length of. You wouldn't even have to put the words the length of line segment xz. But you're right. They do write the word length of. Usually they don't. I'm not sure why they did it there. All right, let's do this. What did we say about those two segments? What did we say about that 6.5 and that 7.3? What do they do to become 13.8? They add up. So look at this. What about this 8 and this 2x plus 7? They add up, don't they? What do they add up to be? The whole thing, 4x plus 3. Exactly right. So let's set it up. So it's 8 plus 2x plus 7 equals 4x plus 3. Some of you guys had a little tough time on this. Remember we had a problem almost just like this on a quiz? No, it doesn't make any difference. Right? Do you remember we had a question like this on a quiz? And a lot of people missed it. All right, hopefully you're going to get it right now when you see it on the test. And you will have one almost just like this. Numbers might be a little different, but you'll have one very, very close to this on the test. So make sure you know what to do with those two segments. You take the two segments, add them up, and it equals the whole thing. Let's do it. Let's add some like terms first. 8 plus 7, that's 15, plus 2x equals, you can't do anything, simplify the right side, so we'll just keep it like that. Let's get x on the same side. You could put the 4x on the left, but I'm going to do this. I'm going to take the 2x and put it on the right-hand side. Well, yeah, just because I want it positive. Okay, it's just a little easier if I get a positive x, don't you think? That's what I usually do. It doesn't matter, though. So, watch. Those will cancel out. Let's do this. Let's get rid of the 3 now. Subtract a 3 from both sides. You remember this from Algebra 1, don't you? All right, what do we get? We get a 12 over here, and we get a 2x right here. Right? 4x minus 2x is 2x. Divide both sides by 2. What's x? How about 6? All right? Is that my answer? Do I circle it? Am I done? Go on to the next problem? No, what's the problem say to do? Find what? Find the length of xz. So 6 is not the length of xz, is it? That's right. You got to put it in for this, right? There's your xz right there, isn't it? You just found x, so you take what x is and you plug it in, or replace it, or who's calling me? It's a bride-to-be. I'm shooting her wedding Saturday, and I still haven't really talked to her yet. We've left like 4 different phone messages for each other, but I still can't talk. Okay, here we go. So it's going to be 4 times what? 6 plus 3. What's that? 24. Plus 3 is 27. And now that is what your answer is, isn't it? Okay, that's xz. That's what you're trying to find. It's not too bad, is it? All right. If you're not sure about it, you're not sure about the math that we did right there, go home over the weekend, right? Click on YouTube, find it, and take it step by step. Nice thing about YouTube, you can just sit there and pause, right? If you didn't get something, you can pause, you can go back. You can go back. What's that?
It doesn't show that.
It doesn't show what?
That. Yeah, it shows all of it. Recording all of it.
Yeah. Yeah, the whole thing's being recorded. Is that what your question is? Yeah, everything on here, it's showing. All right, look at 8. Like on number 7 or 6 and 7, they talked about line segments. So what did I do? I drew out the line segment. Well, look at number 8. It says a square. So what am I going to draw? I'm going to draw a square. Okay, it doesn't take too long. Okay, it only takes a couple seconds to do that. So you draw a square. It says it has a side length of 2.3 feet. Now it's a square, isn't it? So what's true about all the sides of a square? They're all the same, equivalent, right? All right, they're all equal to each other. So I'm going to do that. And the question says, what is the area of this square? Well, this is pretty easy. How do you find the area of a square or a rectangle? Length times width, or we could call it what? Base times height. All right, either way, it doesn't make any difference. So what is it? It's 2.3 times 2.3. Or you could go 2.3 what? Squared, right? We'll just do it like that. All right? So you plug those into a calculator, and I believe you get 5.29. Is that right? No, just keep it like that. It comes out exactly 5.29. There's no reason around it. Just keep it the decimal places. Now, is it 5.29 feet? It's area, so it's what? Feet squared. Good. All right? You could say square feet, or you could say feet squared. It doesn't make any difference. Ah, that was an easy one. Y'all got that one, didn't you? Okay. Look at number 9. It's a circle, right? So guess what we're going to draw? Yeah. Crazy like that, isn't it? Alright, there's a circle. You may not really need to draw the circle, but it's nice to visualize what's going on. Look at number 9. It says a circle has the circumference of 6 centimeters. Circumference equals 6. What does that mean? The circumference is the distance what? Around the thing, right. Okay, that's the circumference. Usually they ask you for the circumference, don't they? They'll give you the diameter or the radius, and they ask for it. This time they tell you the circumference, and you got to find something else. What do you think you're going to have to find?
Diameter.
Yeah, they asked for the diameter on this one. Okay, so let's just make it go through like this. Okay, that would be the diameter, wouldn't it? We'll call it D for diameter. Make sense? Well, we have an equation that has circumference and diameter. We actually have two different equations for circumference. They're not really different. They're kind of the same thing, but two ways to look at it. Do you remember what the one with diameter is? Circumference equals what? Say it. Pi times the diameter. That's right. Pi d. Okay? Pi times the diameter. Look, if you know this formula right here, which you should know, you have to have it memorized, because I'm not going to give you these formulas. Remember the formulas you have to memorize? Area of a square, rectangle, area of a triangle, area of a circle, circumference of a circle. You have to have those memorized. Remember the other ones, though? Oh, there's three-dimensional ones, like what? A pyramid, a prism, a sphere, okay, all that kind of stuff, a cone, a cylinder. You don't have to memorize those. But these basic ones, okay, you have to memorize.
What you would do is divide 6 by 5.
That's right. So watch. Let's put the numbers in. What do I know? I know circumference, don't I? Which is 6 equals pi times d. So you know what pi is, right? Pi is a number, isn't it? All right. So, yep, divide this by pi, divide this by pi. Remember how I read off the answer earlier? You could just leave it like that if you want. You're done. You don't even have to put it into a calculator. 6 divided by pi. Just leave it like that if you want to. If you want to throw it into a calculator, you can. You'll get around 1.9, I believe. It is. Because I'm getting d by itself. I'm doing algebra, and I'm getting d by itself, so I divide both sides by pi so that d is by itself. Because I know the circumference this time, right? So I don't know the diameter, so I can't multiply pi by something I don't know, so I got to get it. Right, exactly. Since it's being multiplied, do the opposite, divide both sides by pi. Good. Okay? All right, here's what it is. Now, they give you a graph, right? And you have to look to find where A and B is. We already looked at it. We said A is at -3,1, B is at 4,4. It says find the distance between. So we use the what? The distance formula, and here it is. So let's use it. Put a big square root, couple parentheses, and square both of those. Put an addition in between. Now we subtract the x's. Now, so here's our x's right here. So it's -3 minus 4. Let's subtract the y's. What is it? It's 1 minus 4. -3 minus 4 is -7 squared. 1 minus 4 is -3. We square that. Remember, it's under a square root. This is 49. This is 9 under a square root. And that's the square root of what? 58. That's all there is to it. Simple as that. All right, let's go on to the next video.